Dear students, in today's class, let us discuss the terms of what is electric flux density and Gauss law, right? So electric flux, we all know that the charge notation is Q. So if you have a test charge as Q and the main charge as capital Q, there is a force of interaction between a test charge as well as main charge. This force of interaction between these two charges is called as electric flux and the notation is psi. So this electric flux is equal to the main charge. So this one we must know very clearly that the electric flux between two charges, that is test charge and main charge, will be equal to the charge itself. So the electric flux will be equal to the main charge, right? And the electric flux density. So electric flux density, the notation is D, which is equal to the charge per unit area, that is Q by A. In case if it is a spherical surface, we can write charge Q divided by the area of spherical surface is 4 pi r square. So which is the flux density Q, D is equal to Q divided by 4 pi epsilon r square. And we know that the relationship between D and E, that is flux density and field intensity, is D is equal to epsilon E. This concept also we have to know. So the electric flux is lines of force between test charge and main charge, and that electric flux will be equal to the main charge itself, and the electric flux density is D is equal to charge divided by unit area. So that is another relationship between flux density and field intensity, that is D and E is D is equal to epsilon E, right? So next is Gauss law. So here we are studying for electrostatic field, so that we can also call it as electric Gauss law. Electric Gauss law. The statement for electric Gauss law is that in any closed surface, the electric flux density will be equal to the electric flux density, or the electric flux will be equal to the charge enclosed by the surface. So this is the statement of electric Gauss law. So that is, in any closed surface, the total electric flux will be equal to the charge enclosed by that surface. So which is electric Gauss law, right? So the main applications of Gauss law is we can able to find out the electric field intensity potential by using this electric Gauss law, right? Let us discuss one applications of Gauss law. So that is finding electric field intensity between two concentric shells, right? So here you consider this diagram. So in this, the inner radius of this concentric spherical shell is A, and the outer radius of this concentric spherical shell is B, right? So in between A and B radius, you consider another radius called R, right? So the inner shell consists of a charge Q1 and the outer shell consists of a charge Q2, right? So here our aim is to find out the electric field intensity between these two shells, right? So here we have to use electric Gauss law to find out the electric field intensity, right? Right, okay. By applying Gauss law, that is surface integral of d dot ds is equal to 0, here I have written, right? Actually, according to Gauss law, the electric flux density or electric flux enclosed by the surface will be equal to the charge enclosed, right? Now, by electric Gauss law, if this radius, that considering radius is less than A, that is less than this, inside this intrinsic, that is inside this spherical shell, means there is no charge enclosed. So that we have to write closed surface integral of d dot ds will be equal to 0, because there is no charges enclosed inside this inner spherical shell. So that we have to write that as 0, right? So that instead of d, we can replace the relation d is equal to epsilon E, where D is flux density and E is field intensity. Our aim is to calculate what is the electric field intensity between the cell, right? So that instead of D, we can replace epsilon E. So epsilon E dot ds is equal to 0, so that E becomes 0. That means the electric field intensity between that is inside the spherical shell, that is less than A. If R is less than A means there is no charge enclosed, so that the electric flux intensity will be 0, right? So next, the field intensity between two cells, right? So as I said earlier, outside, that is outside the inner spherical shell, the charge enclosed is Q1, and outside the spherical shell of outer spherical shell, the charge enclosed is Q2. Here we are assuming the field intensity between two spherical shells. That is, here we are finding the electric field intensity between A and B. That is, R is between A and B, right? So that E is equal to, so between this case, the charge enclosed is Q1, right? So that we know that the electric field intensity formula is E is equal to Q by 4 pi epsilon R square. So this is general formula. And here the charge enclosed in the outside of the inner spherical shell and in between the outermost spherical shell is R, right? So that the charge enclosed is Q1 here, so that E is equal to Q1 divided by 4 pi epsilon R square. So that is, in between the two spherical shell, the electric field intensity is Q divided by 4 pi epsilon R square, right? So field intensity just outside both the cells, that is R is greater than B means, here you have to add both the charges. That is after the inner cell, the charge enclosed is Q1, and after the outer cell, the charge enclosed is Q2, so that we are finding field intensity just outside of both the cells, so that you have to add both the charges. So your electric field intensity becomes E is equal to Q1 plus Q2 divided by 4 pi epsilon R square. So that is, here you are considering R is greater than A and greater than B, right? So at the inner shell and outer cell, in the sense, at the inner cell means R value becomes A, right? So that E becomes, that is electric field intensity becomes Q1 divided by 4 pi epsilon A square, because the radius is A for inner spherical shell. So that the electric field intensity becomes Q1 divided by 4 pi epsilon A square. And at the outer shell, so here outer cell in the sense you have to add both the charges, so that E becomes Q1 plus Q2 divided by 4 pi epsilon B square, because outer spherical shell radius is B, so that E becomes Q1 plus Q2 divided by 4 pi epsilon B square. So likewise, we can able to find out, after finding the electric field intensity, we can also find out the potential inside the cell, outside the cell, between the shell, using electric Gauss law. So which is the main applications of electric Gauss law.